When we took the inverses of functions with one radical, we noticed a certain kind of polynomial function turning up over and over again. In particular, we noticed polynomial functions with one occurrence of the variable turning up as the inverses of radical functions. And we see the same thing happening the other way round. If we have a polynomial function with one occurrence of the variable, we can invert it. Now, one small thing to mention, if the power is even, we need a domain restriction. But more on that later. Let's see one with an odd power first. Let's say f of x is x minus 5 cubed plus 4. Let's say we want to find f inverse. So we're going to start out exactly the way we did with the radicals, namely by isolating the weird thing. In this case, we're going to isolate the power part, x minus 5 all to the third. So we'll write y. We'll exchange x and y. We'll get rid of this 4, and now we've isolated the power part. And now we use the definition of the nth root to say if x minus 4 is y minus 5 to the third, then y minus 5 is the cube root of x minus 4. Now we'll add 5 to both sides, and we're done. We'll bring back function notation. F inverse of x is the cube root, x minus 4 plus 5. All right, what about even powers? To be one-to-one, an even power has to have its domain restricted. But there are two ways we could go. We could say, for example, g of x is x to the 6th, where x has to be positive. In that case, when we rewrite this as a radical, we want to say y is the usual 6th root of x. So g inverse of x is the 6th root of x. No problem. But maybe we restrict the domain the other way. Maybe we have, for example, that h of x is x minus 2 to the 4th, where x minus 2 is non-positive. What do we do then? Well, again, we start out this way. But now, when we make the exchange, we want to have y minus 2 turn out to be a negative number. If we say that y minus 2 is just the 4th root of x, the 4th root of x is positive, or 0. So if we want y minus 2 to be a negative number, we throw a negative sign in there. And now we can add 2 to both sides and bring back our function notation. And that's all there is to it. We need to pay attention to the domain restriction so that we know if we want the positive even root or its negative version. It doesn't matter for what we do. We just need to see which one we want.